Okay, we've had some general discussion about water and its part in nutrition. Now we're going to talk about the specific functions of water. First of all, water is a solvent. It's the liquid in which many substances are dissolved to form solutions. It's a transporter. It carries nutrients, waste, and other materials through the body to and from each cell via tissue, fluids, blood, and body secretions. Water is also a regulator of body temperature. It is excreted as perspiration when the temperature goes up, and evaporation of the perspiration cools the body. Water is a lubricant. It's the component of fluid within the joints called synovial fluid, and it provides smooth movement of the joints in the body. Water is the component of all cells. It gives structure and form to the body. And then there's hydrolysis. As water breaks apart substances, especially in metabolism. So you do need to know what the functions of water are, not necessarily the specifics of as a solvent, it's what everything's dissolved into to form solutions, but you do need to know that water serves as a solvent, a transporter, a regulator of body temperature, a lubricant, is the component of all cells, and hydrolysis. Those you will be expected to know that. Classification and sources of water. There are 3 sources of water for the body. Liquid, as it's consumed, including water, coffee, juice, tea, anything liquid that you take in. Foods consumed, especially fruits and vegetables, because they're mostly comprised of water. And then as metabolism, which produces water when oxidation occurs. For digestion, absorption, and storage. Water is not digested, but rather is absorbed and used by the body as we drink it. It's not stored by the body, and it's excreted daily. Water losses are classified as sensible, that the person is aware of, and insensible, that they're not generally aware of. And there are 4 ways that the body normally loses water. Urine. It accounts for the greatest amount of water loss from the body, and that is sensible. You're always aware of urination. And then feces contains a small amount of water, and that's an insensible loss, except in the cases of diarrhea, because you don't actually see the water in your feces. Perspiration, because it varies with the temperature, but some fluid is always lost, and that can be insensible or sensible. In the hot summertime, when you have an excessive amount of perspiration when you exercise, those are sensible. You can see that, but your body is always perspiring to regulate that body temperature, and when you cannot see it, it's not visible to you, it's insensible. And then respiration. That's that loss of moisture with every breath, and that is also an insensible loss because you cannot see that fluid as it's lost. So make sure you are aware of that also. Sensible losses and insensible losses through urine, feces, perspiration, and respiration. We've discussed signs and symptoms of fluid volume deficit and fluid volume excess. Some of the most common symptoms of water deficiency is dehydration. So abnormal water losses from the body can include profuse sweating, vomiting, diarrhea, hemorrhage, wound drainage, especially from burns, fever, and edema. With edema, water is still in the body, but it's not usable. So it's not able to be used, so it is a loss. And all of that deficiency again is called dehydration. Prolonged dehydration results in death. And sometimes there are conditions that cause an excessive accumulation of fluid in the body, and this is called a positive water balance. It occurs more when more water is taken in than is excreted, and edema results. That's an excess. Hypothyroidism, congestive heart failure, hypopropytemia, and some affections and cancers, and renal conditions can cause water retention because this sodium is not being excreted normally. You know where sodium is, water is. Sodium and water go together. So if the body is holding on to the sodium, it's holding on to water. You should be able to recall some of the signs and symptoms of dehydration. especially those listed on page 367 in the professional tip box. Decreased urine output, a urine-specific gravity greater than 1.035, a weight loss of 3 to 5% for mild dehydration, 6 to 9 for moderate, and 10 to 15 for severe dehydration. Those numbers will be important to you. The eyes appear sunken. The tongue displays increased furrows and fissures. The oral mucous membranes are dry. Decreased skin turgor. Venous filling and emptying is delayed. So your capillary refill is going to be greater than 3 seconds, usually about 3 to 5 seconds. In infants, fontanelles are sunken. And then there are changes in neurological status that may occur with moderate to severe dehydration. You have to also remember that dehydration in infants, small children, and the elderly has greater effects. They're more susceptible to dehydration, and they can cause more problems, and occurs more rapidly and is typically more severe in those three populations. If you look at this slide helps you remember some of the things. It starts with the head and works its way down. It reminds you that water regulates body temperature, that it moistens tissues for the mouth, eyes, and nose, that it lubricates joints, protects organs and body tissues, helps prevent constipation, which again becomes increasingly important in your elderly population, reduces the burden on the kidneys and liver by flushing out waste products, helps dissolve minerals and other nutrients, making them accessible to the body, and then carries nutrients and oxygen to the cells. So if this picture can help you remember it, it doesn't remind you about hydrolysis necessarily, but if you can remember these things, it might help you remember the functions of water. Carbohydrates. Carbohydrates are made from carbon, hydrogen, and oxygen. So the abbreviation is CHO. It's the chief constituent, it constitutes the chief source of energy for all body functions. Also makes up a major food source for people because they're the least expensive and the most abundant foods. It is recommended that carbs make up 50 to 60% of a person's kilocalorie intake per day. And it's estimated that the U.S. current diets only take about 45% of their kilocalories per day from carbs. So we're a little under what we should be doing. The functions of carbs, their primary source of energy for the body. The body must maintain a constant supply of energy, and so it stores about half a day's supply of carbs in the liver and muscles to use whenever it needs to do so. A sufficient supply of carbs spares proteins from being used for energy, and allows proteins to perform their primary function of building and repairing body tissues. So carbs, the energy source, store half a day supply in the liver and the muscles so that it spares proteins. Proteins can do their job. Carbs are also needed to oxidize fats completely and for synthesis of fatty acids and amino acids as well. The central nervous system and erythrocytes rely solely on carbs for energy. You will need to know that. The central nervous system and erythrocytes rely solely on carbs for energy. So if you have a diet that's deficient in carbohydrates, then the central nervous system and the erythrocytes can't pull what they need to get their job done. Carbs are classified as either simple or complex. Simple carbs are single sugared monosaccharides, like glucose and fructose, that are found in fruits, honey, and corn syrup. Monosaccharides require no digestion, they're quickly absorbed, and they're used for energy or stored as glycogen. Those double sugars, which are disaccharides, include sucrose, maltose, lactose. It's when two single sugars join together. They're found in milk, sweeteners, sugar, and molasses. They can be absorbed by the body, but they must be separated into monosaccharides through digestion. Complex carbs are polysaccharides. There are many sugars joined together. They're important in nutrition, and the ones that are most important are starch, glycogen, and dietary fiber, or cellulose. The most significant of these in the diet is starch, and the starch is found in grains, grain products, legumes, potatoes, and other vegetables. Um, Complex carbs are digested much more slowly than simple carbs, and they supply the body with energy for a longer period of time. Um, Maybe this will help you understand when you have a diabetic person who has a very low blood sugar. If you stick their finger in their blood sugars less than 60, say 40, you're going to give them those simple sugars, that orange juice with packs of sugar in it, that candy, those cookies, something that's simple, those simple sugars, so that it can be easily digested. It's going to bring that blood sugar back up. But if you do not follow through and give them a complex carb, like peanut butter or something that's going to take longer and last in their system longer, then they're gonna raise their blood sugar, and then just as quickly as it went up, it's gonna drop back down. They're gonna bottom out again because you don't have anything following it to stabilize it. So you've got to give them a simple sugar, orange juice with sugar in it, cookies, candy, something quick to get that blood sugar back up, because it's going to break down into what it needs to do, and then give them a complex carb behind it so that it stabilizes and levels off. Brings that blood sugar back up to where it needs to be, and then levels it off again instead of bringing it up. And when those things are used up, then that blood sugar plummets right back down, and sometimes it can be even worse the second time than it was the first. So think about that with your diabetic patients. And then you have glycogen. Glycogen is a form of a carbohydrate made by the liver, stored in the liver and the muscles. The body keeps a 12 to 48 hour store of glycogen. This glycogen that's stored is used as a reserve between meals and during sleep to maintain euglycemia, just simple normal blood sugar. Okay. Glycogenesis is the process of converting glucose to glycogen. Glycogenolysis is the process of changing the glycogen back to glucose when it's needed by the body for energy. Insulin is that pancreatic hormone that's necessary for cells to produce energy and for the liver to produce and store glycogen. Glucose metabolism depends on the availability of insulin. So think about this. Glycogen is a carbohydrate. It's used as a reserve between meals to maintain that euglycemia, that normal blood sugar level. When the body needs glycogen, it takes the glucose that's in there, converts it to glycogen through glycogenesis. When it needs energy, it's going to convert the glycogen back to glucose through glycogenolysis. Okay? So that glucose metabolism depends on insulin. Dietary fiber has no nutritive value. The human body is unable to digest it. There are two types of fiber, soluble and insoluble. Soluble slows gastric emptying and binds with bile acids and cholesterol. It provides the satiety and lowers the cholesterol level in the blood. Insoluble dietary fiber holds water, which increases the fecal bulk and stimulates peristalsis for better elimination. Fiber sources, whole grains, whole grain products, legumes, fruits, and vegetables, especially with the skin. So those are all your fiber sources. So make sure that you are aware of what your fiber sources are as well. Okay?